Welcome everybody to week 15, day 2 of second semester of game development. We'll continue our discussion of acceleration structures today. Acceleration structures are things that make games go faster. And we talked last time about binary space partitions, quadtrees and octrees, which are all kind of in the same general ballpark of idea, although they're a little bit different, obviously. Octrees are 3D versions of quadtrees, and BSPs are kind of like, they're binary trees instead of quadtrees, and they don't line up along the axes. They kind of they can split the world any way they want. So if you're intelligent about it, you can come up with a better tree structure. The other major acceleration structure that you need to know is called a BVH. Bounding volume hierarchy. Those marks there. BVH, bounding volume hierarchy. And so what you can do is, if you have 3 objects like this, you can surround them all in either bounding spheres or bounding boxes and do something like this. And then you might have another group of them over here, and building them is one of those things where, oh, I just grabbed my video screen. It's like one of those things that requires, intelligence also. And then the whole world might be wrapped in another. This is supposed to be a circle, by the way, the radius and a center point and a radius. And so with a BVH, what happens if you shoot a trace line, or if you want to do a point contents check or something like that, point contents, what you do is you see, is the point within the radius of the circle? If it is, all right, cool. Look at the 2 children that we have. Is it within the radius of one of them? Yes, it is. It's in the left one. All right, cool. All right, go within its 3 children. Is it within the radius of one of the 3 children? Yes, it is. Which one? C. Return. Hit. What's it within? C. For a line trace, you start by seeing if the line hits the circle at all. That's a very easy determination to make. Circles are very easy to work with, as are bounding boxes. And then that's the nearest, like if that's the origin point, the nearest point is like that. It's kind of the way you do it. And if it misses the entire thing, it's a miss. Just right. It doesn't hit anything. If it does hit, then you go inside of it. And from here, in this direction, you see if it hits either of these things. Miss, miss. It hits the edge here. There's nothing else. It's a miss. And so point contents and trace lines are 2 very common checks. Another one's a radius search, where you like intersect a circle with a circle, and then you have to go through every, because you could hit like multiple things, right, with a radius search, and so you have to kind of go through everybody in the area. So what we're going to do for your homework assignment is we're going to do a quad tree. And a quad tree is, like I said, it's what I use. I used octrees because it's 3D, but the principle's the same. A quad tree is basically a tree structure with 4 kids corresponding to upper left, lower left, upper right, a lower right, and which order you put them in. Matters, actually. It actually matters what order you put them in when you're doing like a line trace. So like if you've got a world with like boxes in it, there's a top-down view, obviously. It's like a warehouse or something. And you're doing a line trace and you want to see if it hits something. You should start in the lower left quadrant first, because if it hits anything in here, then you don't need to check the lower right, because it does hit the lower right, but the upper right. So there's when you store it just like normally, it's like whatever, put them in whatever order you want. But if you ever do a line trace, it's common to shuffle these so that, okay, this is to the lower left of the origin of the tree, so start with the lower left corner, and then when you exit it, you find out, are you transition, if you shot this way, right, you can find out where the x-intercept and the y-intercept are, right? And then you check this one, and then when you exit that one, you check this one, and you don't check the upper right at all. So the order doesn't matter on its own, but when you do a line trace, it's normal to put them you know, in order based on, because if you hit a box here, you need to stop, right, before you hit this box. You have to search them in a certain order. So let's go ahead and do this on the server, and see if we can like maybe put together like a top down shooter or something like that in a little bit of time. We've got 40 minutes today. That's not going to be enough time to do it from scratch, but let's see what we can do, at least as far as the quad tree goes. Maybe we'll do point contents. That's pretty easy. And then I'll see what I want you guys to do on it. So cd quad tree reference. What's there space there? It's spaced out because of the. Yeah, okay. Alright, so, yeah, okay, you know, I'm just going to push out the homework to you guys. Sudo deploy homework, is50, b fall21, quad tree. So, let's take a look at the, let's take a look at the reference implementation first, and then we'll see what there's to see. So when I run it, first point is going to be at 0, 0. Second point is going to be at 5, 0, 50. Okay, 0. Ouch. Okay, and then the third one's going to be at 25, 25. Okay, content ID is 1. Okay, so that covered up the world. Cool. Neat. All right. So how many rows and columns is this? Probably print this out. See how. Okay, so it goes from 0, 0 to row 31, column 118. So we'll start at like row 15, column 50. That's kind of like the midpoint of the world. We'll go down to row 30, column 100. So it's midpoint to the bottom right corner of the screen. And then we'll cut back over to row 30, column 1. Interesting. Segfault. Who wrote this code? Did I go out of bounds? I must have gone out of bounds or something. So let's take a look at our triangle code here. So, oh, I see. Yeah. So every triangle can either be open air, solid, water, lava, or grass. Maybe I didn't finish implementing this, actually, now that I think of it. So when we echo it to the screen, oh, this is the content. Yeah, okay. The triangle itself has 3 points in it, and content, right. Okay. Is inside, so this is code that will tell you if something is inside of a triangle. Barycentric coordinates, and yeah. So if the, so this is going to return true if a point is inside of a triangle. All right. So let's just take a look at what you're supposed to do. I seem to recall that I didn't actually do it myself. I think I did part of it. Then quadtree.h. Okay. Yeah, I think this is pretty. Well, maybe I did it. Maybe I did. I don't know. It's been a while. So here's the quad tree class that I'm giving you. So every quad tree represents a quad. It represents a quadrilateral area on the screen. So by default, the root quad tree is going to cover the screen, 31 rows, 118 columns, and that is the top left corner, bottom right corner. Top left corner will be sorry, top left corner and then the size. So you sometimes hold a rectangle with the two corners. Sometimes you hold it with one corner and a size, and it just kind of depends on the math you're going to do, which one's easier for you. In this case, we're going to hold 0, 0, and then the size, the number of rows, the number of columns. And then it starts off with all 4 of its kids being null. Okay, and that means it's a leaf. If all 4 of your kids are null, you're a leaf node. And so when you go to render it, you just render the whole region. Yeah, there you go. So when you go to render it, you're gonna do something like saying, starting at the top left corner, going to the bottom right corner, echo whatever content I am. Every quadrilateral region will be the same content, and so you're going to be putting triangles on the map, but the quad tree holds rectangles, and so that's amusing to me. So it's going to split all the way down to probably the single pixel level for a lot of them. What? Yeah. So the quad tree holds quadrilateral regions, right? But when you mark areas on the map as lava, you're going to be putting triangles on the map. And so what you're going to do probably is go through and add each pixel each point inside of the triangle one at a time to the quad tree. And yeah, or I don't know. Maybe make your code do rectangles or points instead. That might be easier. I don't know. So quadrilaterals. Yeah. So when you render it, you're just going to render the whole rectangle the same color. And so do you guys remember how to do that using colors.h? You guys remember how to draw a rectangle on the screen? I'm like, just because so many programming needs to be done. Yeah, I thought. Yeah. So, okay. So, if all of your kids are null, then you're just going to draw the rectangle that corresponds to you to the screen. And open is whatever color open is. I don't know. But here's how you do it. I'll just do this one for you. Not you anymore. I'm going to implement this one for you. So what if one of our kids is set and the others aren't? I don't think we can do that in this version. Either all the kids are set or none of them. Yeah, that's how we're doing this one. Okay. So if we could just have a Boolean that we're a leaf node. All right. Let's figure it out here. Bool leaf node is equal to the upper left not being null, and the upper right not being null, and the down left not being null, and the down right not being null. Okay. So if all 3 of them are not null, we're not null. Or we're... Sorry. No. This is the opposite. You have to not this. So if all of them are... No. Actually, we just check one of them. Right. So if... yeah, so if the upper left one's null, we're a leaf. Because all of them are set to null, or none of them are set to null. So we only technically need to check one. Although out of safety, we probably should check more. Okay, so if we're a leaf if one of our kids is null, because then all of them are. Okay. So if we're a leaf node, then we're responsible for rendering the 2D region that we're within, that we represent. This is the 2D region we represent. So we could represent the region starting at row 12, column 5, 2 to the right, 2 down. And so when we render it, we're going to render it in whatever color that is. So let me just show you guys how to do this in using the colors library. So we need to set all of it's going to be the same color, so that's easy. So we just see out did I have a thing? I thought I had a thing. Maybe that was in my implementation. I did have a thing. All right. I use an enum class for this. Go me. All right. Mark X, Y single quote X, edit, Quadtree, triangle.h. Rather than using that nonsense, we're going to use a enum class. Heck yeah. And this will require us to include okay, so I'm doing colors using an enum class instead of just constants like we did before. This is going to probably break a lot of stuff. So yeah, instead of content, this will be a content. So rather than an integer, we're going to hold a content. And the reason why I did that is because then if you try couting a content, what it's actually going to do, it's going to see out, it's actually just going to call a function that will set the color for that. So I could see out lava, and rather than printing anything to the screen, it just changes the background color to red. So that's kind of cool. It's kind of a neat little thing there. All right. Yeah, all right. All right. Content here. And because I have the double right arrow operator overloaded for the content enum class, then this actually works. You can type in a number and it will convert it into the appropriate enum class thing. Lava, forest, whatever. Include quadtree.h. I don't know what you are, so we'll get rid of you. Maybe we shouldn't have done that. I don't know what I was mad about then. Okay. No? What are you mad about? You're mad about something. Oh, the content. Yeah, content has to be content. Refactoring code, always fun. Okay. So, where were we? Right. So, we did all that simply because I wanted to be able to do this. I wanted to see out my content, and that rather than so the content's gonna be like grass or lava or a lake or something like that. So rather than it actually printing anything to the screen, it actually just changes the background color to whatever it matches. So all that refactoring was simply to have a small convenience for me. So we're going to render a rectangle on the screen, and we're going to do that by starting at for int row equals min dot x and y. That's not row 12, that's x12. Rather than x and y. Oh, man, I don't want to mess with this. Dang it. Because 12.5 should be x is column 12, row 5. Column 12, row 2, or row 5. Okay, I'll just fix the comment. It's the easiest way of doing it. All right, so more refactoring debugging, always. Yeah, Frankahedron. Yeah. So, yes, for this assignment, we're not doing the trace line thing just yet. We're just gonna do this. So you're gonna have a quad tree, and maybe one of the quadrants will be red, and the other three will be open or something like that. Or you can color this part in red, something like that. All right. Okay, so let's draw a rectangle on the screen. Having you guys do triangles is kind of mean. Kind of is. Kind of want to redo this assignment now. Let's... Rectangles, if I gave you a rectangle to draw, it'd be a lot easier. Triangles are mean, yeah, because the quad tree is rectangles, and I'm going to be telling you draw a red triangle on the screen. And so you're going to have to split it and... I don't know. That's funny. Yeah, maybe I'll redo this assignment for you. Okay. Anyway, let's show you how to do this. Yeah, it's funny though. Okay, so int row equals min dot y, as long as row is less than or equal to. Sorry. Min dot y, as long as row is less than or equal to min dot y plus size dot y, row plus plus. So this holds the top left corner, and size holds how big we are. And there's always a question of if it's inclusive or exclusive. So if it's the size of 0, 0, do you draw anything at all? I think it should, maybe. I don't know. Size of 1. I don't know. Maybe not. Should it? If you have size 0, 0, should you render? I don't know. Maybe not. Maybe 1, 1 should draw 1 pixel on the screen. Yeah. Well, in that case, it'll be less than. Okay. And then IPY paste for every column from min.x. Column is less than min.x plus size.x. Column plus plus. So for every row, for every column within the rectangle, we're going to move the cursor to row and column. Ooh, that doesn't exist yet, does it? So before we print out all the things on a row, we move the cursor to the first spot on the row, and then we're going to see out a bunch of spaces. See out a space. And because the background color is set to red or whatever, it'll draw a red box on the screen. And so this is going to move the cursor to a certain spot, and then if the thing is 10 boxes long, it'll draw 10 red boxes on the screen. Then when it goes down to the next line, move cursor is going to move to the next row and column and draw 10 on the line, and it's going to do a red rectangle this way. So take out all of this, take out all of that, and just say world.render. Just see what we got here. Warning, no return statement. Ah, right. So drew a bunch of black on the screen. That's cool. Is that correct? Maybe. Might actually be correct. Because it's open. Open's supposed to be black, I think. So rather than outputting that, let's output content lava. Ooh, doesn't like that. I lava you. There we go. Yeah, it's all red. All right, cool. So, but the X and the Y coordinates are all screwed up. So, yeah, we did have it right before. Everything's red now. All right. Everything's red. Everything's lava. So let's make it draw over like part of the screen. Voila. So the quad tree here is going to have, it's going to go from 2020 to 3030, and which one is rows, which one is columns, I think might be hopelessly confused. Not from 2020 to 3030, it's 2020 with a size of 30 and a size of 30. So let's make this 10. Let's see. Should be 10 columns. Okay. Yeah. Okay. That's correct. That is 10 columns. Okay. So, what do we do with a quad tree? What the original homework assignment was that you'd be basically making a map editor. So you'd be placing regions of lava and grass and things like that onto the world, and then the quad tree would sort of accelerate tests against it. So like if you did a hit scan, you would see what you hit, you know. And my kind of goal with this is to do like a top-down shooter. So you use WASD to move around on the screen. You can click, and then lines would come out and impact different things, and maybe have monsters running around and stuff like that. But this assignment's a little mean right now because you would have to mapping a triangle onto a rectangular region is just kind of be a pain because you're going to go 1 point at a time through the triangle, and yeah. Yeah. Okay. So I think I'll refactor this for you guys. I think this is too hard right now, honestly. So I think what I'd like for you to do is points or rectangles. Maybe rectangles. So right now the entire quad tree is one color. And I think what I want to do instead is have a quad tree just contain bounding boxes within it. And so you could like place boxes around the map and then have your player walk around and shoot and have it impact boxes, because that's more of a realistic application for these things, rather than having the entire region in a quad tree be one color. Yeah. Okay. So I'm gonna redo this. So I'll redo this for you. So let's just talk about the algorithm. Okay, let's talk about the algorithm. We've got 10 minutes left. So how would you do this? So like let's talk about this. So let's say that you've got a world, and you got boxes in it, right? Some of them are not going to be nice enough to fall on one side of the quad tree or another. So what you do with a quad tree is every quad tree is going to have the 4 kids, right? So you're going to have the quad tree, and it's going to have the 4 kids, left, pointers, the left, lower left, lower right, upper left, upper right. I think called it down left, down right, doesn't matter. You're going to have 4 kids, and if your kid is null, that means there's nothing in there, basically. If there is a kid, then there's something in that direction. So what you do is you have some sort of threshold for subdivision. So let's say your threshold is like more than 2 boxes. Okay. In that case, when you build this data structure, you start off with just the root, and so it's not even divided into 4 quadrants yet. You start off with your root node, and the root node corresponds to the entire damn world. And you say, are there more than 2 boxes within me? Yes, I am. Therefore, subdivide. Okay, cool. So then you divide your world into halvesies and halvesies, which forms quadrants. And you go through the list. You're going to have basically a list. Let's do this in green, I guess. You're going to have like a list, or a vector is, what it could be, a list of boxes, and that's going to have all the boxes that were within the region here. And what you do when you realize the list of boxes has a size greater than 2, and this threshold is configurable, like you kind of look at your tree and see if it's ridiculous or not. Like if you're making a tree that's like 1,000 levels deep, you probably need to raise the threshold. There's kind of a trade-off. It's a tunable parameter. So what you do is you say, all right, if the list of boxes within me is greater than 2, subdivide. And you're going to pass all the boxes in here to one of your 4 kids. So you start off by newing each of your 4 kids. So you say lower left is equal to new quad tree. and ditto for the other ones. And then what you do is you say for every box in boxes, you figure out which quadrant, and that's pretty easy by and large. Is it to the top left? It goes to the upper left. If it's in the bottom right, it goes to the bottom right. There is just a little bit of trickiness when they span an intersection. Then it's going to be a kit of all 4 of them. Okay? So, that's the only tricky bit, is handling things that are on all 4 sides. And what you can actually do is you can actually split that box. It's like if it's on 2 sides, you can actually cut it in half and make a box here and a box here. It's one way of doing it, or you just have it on as a kit of multiple ones. And so you basically just say, if for every box in the boxes vector, if it's within the upper left quadrant, add it to the upper left kid. If it's in the upper right quadrant, add it to the upper right kid. If it's in the bottom right quadrant, add it to the bottom right kid. If it's in the bottom left quadrant, add it to the bottom left kid. And so this guy could get added to all 4 of them feasibly. And then you recurse. You repeat this process for the upper left kid. Do I have too many boxes? Yes, I do. So then it will subdivide. Yoink. Yoink. And for every box that it's in its list, it'll pass them to one of the 4 kids. All right, you go into the upper left. You, nobody here, nobody here. Oh, you go into the bottom right. You go into the bottom right. And then you're done. You've now successfully subdivided. For this one, we subdivide. This box is going to get passed into 3 of them. This one has 3 boxes. This one has 2 boxes. 2 boxes. And so we're done with this one. We're done with this one. This one, and this one has 2, so that's fine. But this one's going to get subdivided again. And that one has 1. That one has 2. This one has 2. This one has 2. So we're done. All right. And then for this one, subdivide. Subdivide. Top left area has 3. Subdivide. And we're good. This is what the quadtree looks like. So quadtrees are interesting because they'll have more density in the areas where there's more dense stuff. And they're going to have big, open, empty rectangles in areas where there's not a whole lot. And so it makes a ray trace really easy to do. Because if you were to shoot from here, let's say you're shooting up this way, you do a point contents, like where do I hit? Okay, that spot. And then you do the line algorithm and you just see where you see, is there anybody in this? Nope. All right, figure out the exit point. And then you go to the neighboring square. You're like, all right, this is my entrance point. This is the direction I'm going in. Did I hit anything? There's only 1 square within this square. And so you do a line square intersection test, which we've gone over before. It's pretty easy to tell if a line hits a rectangle or not. It doesn't. So, okay, it exits the square here. And then you go into this one. And you go up this way. Do I hit any squares? Yes, I do. Where? Here. And that's how you do it. And so you can search this whole world, which might have thousands and millions of boxes in it, by doing 1, 2, 3, 4 tests. And all these tests are very simple. They're all just algebra. And I could probably go over those again at some point. Okay. Looks very Christmassy. Okay. So what I'd like for you to do for your homework assignment is build the quad tree and then just do a point contents test. So if I ask you, hey, who did that spot hit? You'd be like, oh, it's box number 23 or whatever. Okay. All the boxes are going to be axis aligned bounding boxes, so they're going to all be like that. They're not going to be at an angle like I have. Okay. Hey, what did this spot hit? Nothing. Hey, what did this spot hit? That hit box 12. Okay. And you're going to tell me how many levels down in the quad tree it was. And that's how I can tell you're doing a quad tree and not just using the vector of boxes, which you could probably do to cheat your way through it by just not doing a quad tree at all and not having an acceleration structure. But remember, the whole point of doing this is to get our speed from order n to order log n, right? And it's not guaranteed. Quad trees can be degenerate. You could have, if all of your boxes were on the same spot you know, then the quad tree would just sort of infinitely subdivide, and so sometimes rather than a threshold of like 2 boxes or a threshold of 5 or whatever, they'll set a threshold of like max depth of like 10 or something like that. So it can't subdivide more than 10 times. You know what I mean? And that would give you a max resolution of like 1024 by 1024, right? Subdivide, subdivide, subdivide. So whatever size this corresponds to. So your quad tree would have a maximum of 1024 subdivision. So if you have a really large world, this might not be enough, right? Because each of the buckets might actually be a kilometer. You know, so you might, these are tunable parameters. You want to mess with them and get a performance, whatever is, and you just sit there. You'll just change the numbers, recompile, benchmark it, see which one gives you the best performance. Okay. Right, 4 o'clock. So create a quad tree, and don't even worry about the rendering. I'm probably gonna rip out all the code almost, except for the class for the quad tree, so you don't have to type that up. It's kind of boilerplatey. None of the triangle stuff, none of the lava stuff. We're just gonna have a box class, and there's gonna be a world full of boxes, and you're gonna make a quad tree out of it using these tunable parameters, and then just do point contents. Is that in a box? True or false? Is that in a box? True or false? Is that in a box? True or false? Okay, so that'll drastically scale down the scope, but at the same time, it's actually going to be probably a little bit more realistic than what I was trying to do before. I was kind of envisioning like a map editor kind of thing, and I don't really know where I was going with that. Like, you could like paint a map, and the quad tree would hold. I don't know. So this will be actually closer to what you actually do in a game. Somebody will be walking around, they'll shoot, and the quad tree will accelerate this collision detection. Okay. If done right, you can see if you hit a box and order login time rather than order end time. There you go. And then maybe next time we can, in class together, we can like do a little WASD and have a person run around on the screen and click and shoot and have monsters. I don't know. Sounds like a couple hours worth of work, but should be fun. Okay, that's it for today, guys. And yeah, so ignore the quad tree thing that I pushed out. Do I have a ability to delete that from you guys? Recall homework. Yes, sudo recall homework. IS50B quad tree. You must be sure before you recall a homework assignment. Am I not sure? How do I be sure? I don't even know what I'm doing. What is this? How am I sure? I have sudo. I'm sure. You have to type in I'm sure. All right. I'm sure. Done. Dead. All right. So I'll work on that tonight. All right. Sudo means run as root access. So if you're going to try and run a sudo, it would say you can't, you don't have permission. Hopefully. If you could run a sudo, there would be something tragically wrong going on my server. But sudo means run as root access. And so normally I, as a normal user on the system, cannot do anything to your account. And you can't do anything to my account. If I run as root access, I gain access to the entire server. And so if I were to like want to push a directory out to you, I have to run it as root. And so every time I deploy homework, collect homework, recall a homework like I just did right there, I have to run it as root. And then that allows me to go into students' directories and mess with their files. When I become somebody, that's run as root also. So you can't do that normally. My account is just a regular account. It's not a super user account. But the sudoers file, there's a file called sudoers that controls all that kind of stuff. You have to do those things with sudo to let the server know. Yeah, let me show you. It's a good question. So like if I become Dahlin, she tries to broadcast something to the whole server. Dang it, I don't know her password. It'll say permission denied. Okay, but for me, if I said sudo wall hi, then it broadcasts a message hi to everybody on the server. And yeah, and so there's a file called sudoers, sudoers. And so this lists the permissions of everybody on the server. So root has access to everything. There's a group called sudo, and everybody in the sudo group has access to sudo. And so if I were to add you to that group, then you too would have sudo access on the server. And there's also the admin group, which is the same as the sudo group, except they have to type in their own password. People who are in the sudo group, I could just, you notice that when I did this, it didn't prompt me for my password. And the reason for that is because I got annoyed at constantly having to type in my password every time I push out homework and collect homework and stuff like that, so I just turned it off. Which is not safe. It's not secure. If any student ever sits down at my computer when I'm away, they could just be like sudo rm that's funny -rf, delete the whole hacked. Right. So if anybody were to sit down on my computer, when I'm away from it, they could wipe the entire server. So it's really not a good security system. But at the same time, the students, don't do that. Surprisingly, I've never really had any sudo delete server. No. That's funny. Purge user Rivetcher. So he was messing with me, so I've now kicked him off the server. He has been purged. What's up, Zach? So it makes it not secure but faster to do things, yeah. So yeah. Yeah. So Zach, we're doing computational geometry right now in IS50V. It's something we didn't do when you were taking it. But yeah, it's good to know. It's good stuff. If you're a computer science major, at some point you're going to need to learn how to run a system and stuff like that. So, all right, well, that's it for today. Yeah, I'm done, Mace. And he keeps opening the door. Okay, so I'll see you guys on Tuesday. Peace out.